Hello, geometry students. Welcome back to another video lesson with me, Mr. G. Today we're going to continue looking at inscribed angles from arcs and vice versa. I just want to go a little bit more in depth with maybe what we would consider some more complicated looking ones. So again, I'm hoping that you know the difference between inscribed and central. So let me just draw one more picture, make sure we understand this concept, right? That again, if this is my center, central angle has a vertex at the center. So if this is 80, so is this, because it goes to the center. Versus the inscribed angle, let's say that was our as a center here, but it goes something like, oops, come on, Mr. G, draw straight. Something, I don't know, like so. Whereas this is 120 up here, the inscribed angle down here is 60, right? It's half. And then don't forget the other thing that we also talked about yesterday in our video and even in our live sessions is using the diameter. That if we have a diameter, each half arc was 180 or the straight angle was 180. Okay, and that's going to become very important in what we're looking at today. So here's an example, right? Find the measure of each of these below. 4 different problems. The measure of BDC, so from B to D to C. All right, that's number 1 right here. B to D to C. Find the measure of B to C to D. So this is problem number 2 up there. Find the measure of arc DE. So this is problem number 3. And then the major arc C to B to D. Going all the way around here. And in order for us to, really be able to identify what we're working with, we should start to label some of the things that we truly maybe know, right? Like, for example, if I know this angle is 28 and that its vertex sits on the circle, if I follow the angle, you might be able to see the arc that it hits. Right there's that arc. Well, therefore, if this is 28, it had to be half of the arc. So what is the arc measure? The arc measure out here would be 56. So that's one part of it. What else do we know? Well, maybe you notice that we've also got a diameter here. Let's maybe try that in blue. We got a diameter, right? From D to B, it goes right through the center A. So that's a diameter, which means this half of the circle has to be 180, and so does that half, 180, right? The whole entire half has to be 180. Well, we already know that from B to C is 100, so therefore that leaves 80 for this arc. 80 for that arc. Well, now we also know down here, if this is 180 from B to D, we've already got 56. Oh, what does that leave us with? 124 down here. So that should help us. So you see how I'm kind of just piecing together some of the information that they've given me. Now here's another nice nifty part. Notice, if I draw with blue, there's an angle, and go this way. Notice that from BED, this bed, BED, I get 90 down here. Well, how do I get 90? Well, notice this was the diameter, and this arc from D to C to B, we said had to be a total of 180, so that was 90. Well, let's work backwards again. Let's do some more backwards work. Notice if I go this way, because I know from C to B is 100. So now I've got this arc. From C to B is 100. That means the inscribed, so this one would have to be half, which is 50. So that would be 50. There was number 1. B to D to C was 50. You know what? We're going to come back to that. All right, so that was 50. Well, do I know this angle down here? Well, let's draw those other lines the other way. So let's go red. All right, there's the arc, and there's the other arc from C to D. So the angle is down here. If that's 80, the angle down here would have to be 40. And if that's 40 and that's 50, the whole triangle has to be 180. So if the whole triangle is 180, that leaves us with 90 here. Then the only other angle we're missing is this one. Well, again, this is a triangle down here. 90 and 28, plus this have to be 180. So if I take these two away from 180, we're left with 62. And now I think we've got all of the pieces. We've got all three angles, all the arcs. So now let's go back and answer the questions. The measure of angle BDC. So follow that pattern. B to D to C. What was that angle? B to D to C. 50. How about B to C to D? B to C to D, 90. What's the arc DE? This little arc DE? Well, we said that was 56 because it doubled the 28. And then arc, major arc C to B to D. So we've got to go from C to B all the way around here over to D. Or 100 plus 124 plus 56 is 280. So again, we got to piece as much information together as we possibly can. One more example to look at. And this one, I mean, it looks complicated and it looks super confusing. But the good news is, I think it's not that bad. All right. The measure of arc DA. If we look at this whole, now take a moment to draw this diagram and to draw these questions, or write down those questions. All right, the first one, measure of DA. So we're looking right here. If we look, there's an inscribed angle way down here that's 22. How did they get 22? Well, they took half of the arc. So half of something is 22. That means this had to be 44. 44. All right, so that was 44. Now, what else do we have? If this angle in the triangle is 112, what is this angle right here where my red dot is? It's also 112. Those are vertical angles, so 112. If this is 112, what is this measure going to have to be if they create a linear pair? All right, so we got some of those properties here. However, we got an information here. We got 46 right here, 46. Well, if this is 46, let's follow it back to the central angle. Look, it goes right to the center. And if it's a central angle, what would this measure have to be? It would have to be 46. It's a central angle. It's got a center, so this has to be equal. Okay. Then, because of that, we've got an interior triangle, and all triangles have 180. So 112 and 46 is 158, leaving us with 22 for this angle measure. 22. Well, the angle measure is 22, meaning, if we follow it, look at this arc, right? It goes out to this arc right here. And we got 22 by taking half the arc, or this is 44. Well, that's funny. FC is also 44. Huh. Same thing that we got for DA. Well, what about E to F? E to F. Well, this is where we've got to notice that we've got a semicircle right here. And I'm drawing the line off a little bit, right? There's a semicircle. So from this all the way down here to C, from D to C, it has to be 180. I've already got 44 and 46, which is 90. And if that's 90, that means that this would also have to be 90. And then last but not least, what is the measure from C to A to F? C to A all the way here to F, right? What's a whole circle? A whole circle is 360. And if a whole circle is 360, from C, the direction to A to F, the only piece that we're not using is this chunk CF. So I'm going to take away that 44 that we're not using to get an answer of 316. So a lot of different steps going into that, but I think if you piece together some of the information that you might see, you're going to have better luck trying to figure out what is missing and how to complete those problems. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.